In this topic of pure data tutorial, we are trying to have a look of something we call the augmented reality. And in some of the case, we can use it as some form of very precise tracking of the objects in the real world and how we can convert it back into some virtual information. So the reference for this particular topics will be in this form of projects. So this is the React table, and they come with a table where you can use some of those markers to generate or create sound on top of this. We call it the multi-touch table, and the engine behind this table or this form of interaction is the software called ReactiVision, and you can have a look of those marker which has its unique style in some form like an amoeba, and we'll make use of this form of marker and try to play around with the interactivity by putting the marker in front of your webcam and use it to track the position and rotation in a two-dimensional plane. So before that, you might need to download a few pieces of information. So the information being posted in our course website in the VA3460 wordpress.com of the Embodied interaction course. And I put the material in the reference section. So under the reference section, you have general topics on download. The first of them is the marker dictionary. It will contain a trees file, and all the marker information will be maintained in these tree files. And the second one will be a PDF file, so that is the printable version of the marker where you can use it to print out and then cut it into the form you would like to use. So we have already downloaded the material. First of all, this is the PDF file of the marker. And all you need to do is to cut out each one of them, and then you can either use this piece of paper as an interaction device, or normally we will stick this marker under some objects and you will interact with the object directly instead of just a piece of paper. And the other files we have just downloaded is this file all.trees. So it is actually the dictionary which contains all the control information of all those markers maintained in this PDF file. The way we work with the interaction is similar to what we have done in other pure data and GEM exercise. So we create, for example, in this case with an 800 by 600 size of the window with a full screen display of the video. And the new thing is we have to convert first, for example, the video into grayscale by using the pix gray command. And then we go through two new objects. The first one is an thresholding object, which will try to convert the grayscale image into just black and white. And the black and white will be controlled by, for example, the size of the tile. And the black and white image will be fed into this fiducial track objects. And this is actually the fiducial is the marker we are going to track. And it will make use of the dictionary called all.trees. And everything track will be performed by this particular objects, and the output of this objects is a list come with 4 elements. So we're going to analyze each one of those elements to make use of them for interaction design. So the explanation of this one is, if you one of those markers in front of your webcam, it will recognize that particular unique pattern, and each one pattern within the dictionary come with something we call the ID, identifier or identification, and each of the ID is actually a unique number. For example, 38 is one of those marker number, and the next two number boxes will be the X and Y position, and the last one will be the information for the rotation along the Z-axis. So that is the two-dimensional rotation. So we can have a look of the effect for this one. So when I put one piece of the marker in front of the webcam, you can see the number for this one, the identification is 38, and then there will be some changing number in the X, Y, and the rotation information. So if I try to put another one, for example, this one with the marker ID as 21, and you can also see the change in the XY direction. So if I put it, for example, towards the left margin, you can see the reduction in the number of the X coordinate. And if I push it towards the right hand side, you can see it come close to the number 1. And for the Y, if I put it upward, so this is a smaller number, and I put it downward, will be a bigger number. And you can also see the number changes in the rotation. And the unit in the rotation is actually radian. This is not degree, so we might need to convert it back to degree after we have to perform some sort of calculation. So the next step we work on with this one is we try to make use of this number. First of all, the ID you have to think about for yourself whether you would like to have identification for multiple markers. So that means one marker for one particular purpose, and the other one will be just associated with that marker ID. So if we ignore, for example, in this case, the marker ID and just play around with the X, Y, and rotation, we can use whichever marker and use it to control the location and rotation of particular graphics. So what I'm going to do will be using any marker, and I'm going to create, for example, another gem head with a rectangle. So this one will be in the bottom, and this one will be on top. So in the end, we will come up with a rectangle. So the size of rectangle we can experiment. Try to use a rectangle which might just cover up the size of your marker. And then we have two other objects, one for the translate. So we work on with the translation first, and we take a look of the two number X and Y over here. So for the X, is come with the range from 0 to 1, and those operations we have come across multiple times where you can have some form of multiplication, and then afterward you minus the center point for that particular graphics. and we obtain the x coordinate. And for the y, we did similar operation, except that the maximum range will be 8 instead of 10.66. And the center point will be 4. We can also take a note that it may have the reverse in the direction. So we'll do the multiplication with a negative number and a minus with a negative number. So this becomes an addition with the number 4. And then we'll connect these two numbers to the x and y for the translation. And then we go to see how it can work with your marker. So this is the first operation you use, for example, white rectangle, in order to work with your marker. So at this point, I just make use of the x and y position. So the rotation information hasn't been in place yet. So you can also increase the size of the rectangle a bit, such that it can cover most of your marker. And the next step is we try to work on with the rotation. So we'll introduce the rotate XYZ command between the translate and also the rectangle. And we have only one direction for rotation, that is the Z direction, because the current configuration only allows the two-dimensional rotation. So this doesn't allow the rotation in three-dimensional space. So the next step is we try to convert radian into degree. So according to the mathematics, they have the ratio between 180 degree and a pi for the rotation. So what we are going to do is to, first of all, we multiply the radian by 180 degree. And then we do a division by the value pi. So actually the value pi you can obtain from an object. So this is the value pi. You can put a band in order to send the pi value to the argument for division. So after we do the conversion by doing a multiplication of 180 degree and a division by the value pi, so the number in radian will be converted into degree and will send it to the Z rotation. And then we proceed with the verification by first sending the pi over here for division. And then we create everything. So this is the bigger rectangle. So the movement is the translation, and this is the rotation. You can see more or less the rotation of the marker will match the rotation of your rectangle or square in the objects. So this is another way how we can integrate one physical object, so that is the marker, with the motion of a virtual object, that is the white square on the screen, and we can have very precise movement in terms of X and Y translation and Z axis rotation. And if you take a look of this particular number, you can enable, for example, multiple markers for interaction. So each one of the marker can have one specific functionality, so you can make use of them to, for example, drive the movement of some particular character in your scene to follow the location of the marker in terms of position and orientation. So this is the use of the marker by playing around with the technology that has been integrated or promoted by the React table and the ReactiVision engine.